So good morning all of you. Today I am discussing about the remaining part of the pyridine. As I previous classes discussed the basic heterocyclic chemistry of the pyridine, and now see the structure of the pyridine, and this is the content as 6-membered heterocyclic ring and nitrogen in their ring system, and this nitrogen is the tertiary nitrogen. Okay, so the remaining part of this chapter, that is the synthetic methodology, medicinal importance and the chemical reaction. So now coming to the one by one, the chemical in their synthetic methodology, and the synthetic methodology, the most important synthesis of the pyridine synthesis is the known as the hand synthesis. So this synthesis is the important synthesis for the synthesis of the pyridine, and it is the important for examination also. In that cases we taken the two compound and condensation of the two compound occurs. One is the dicarbonyl compound and another is the aldehyde. So in the form of the dicarbonyl compound, we taken a compound which is the acetoacetic acid. So this is the structure of the acetoacetic acid, and we taken the ester of that compound. So the name of this compound is known as the ethyl acetoacetate, and it is the condensed with the aldehyde, and that is the formaldehyde in that cases, to form the pyridine derivative. And in that case, this is the three-step synthesis process. The step 1 is the ethyl acetoacetate. It is the react with the ammonia. So this is the known as the step 1. And in that cases, what happened in that cases, the lone pair of the ammonia, it is the easily react, and that carbonyl group, and it is the produce a compound which is the containing the amino group at the beta position. Okay, so in that cases the final produce is the like that, and there is the formation of the double bond occurs when the oxygen is the removed out from the compound. So that is the NH2, and in that cases that is the attached with the C2H5. So that is the formation of the first, that is the known as the beta amino protonic ester, and this synthesis is the step 1 synthesis. In the step 2 synthesis, we taken another molecule of the acetoacetic ester. So there is the two molecule of the acetoacetic ester required for that synthesis. So in that cases, that is the react with the aldehyde present. So this is the aldehyde molecule, and that is the HO double bond O. So in that cases, this is the react with that compound of that is the this CH2 group, and this CH2 group is the react at that position. This is the open up that reaction, and this is the produce the final compound which is the CH2 C. Here is the double bond O, and that case is present, and this cases this is the produced alkene derivative, and this CH is the one is the attached with the double bond CH2, and another one is the C2H5. So this is the alkylidine derivative, and or you can say this is the alkylidine acetoacetic ester derivative. and the final step of that compound, it is the reaction of that two compound, or you can say that is the addition of the two compound which obtained from the step 1 and step 2, and there is the addition occurs, and this is the known as the Mitchell or Michael type of the addition. Let's draw the third step of compound. So in the start case we obtain the first compound, that is the amino derivative of acetoacetate ester, and which is react with the alkyl derivative of the acetoacetate ester, so this is the two compound, and there is the addition occurs in that cases. This is the known as the Michael type of the addition. This is the known as the Michael type of the addition, and there is the addition occurs in that cases, as there is this double bond O. This double bond group is the easily attached at the this position, and here is the addition reaction is the occurs in that cases, and it is the C2H5. This C is attached, and that is the it is the attached with the CH3, and this CH3 here is the O minus. Okay, and here this is the CH, means here is the C2H5 and double bond, and carbon is the attached, one is the methyl, another one is the ammonia. So this addition is the known as the Michael type of the addition. In further cases, what happened is that there is the hydrogen transfer is the occurs in that cases, and this for that reaction there is the formation of the double bond is the occurs, and because of the this is the transfer to that position, and there is the formation of the double bond occurs, and it is the positive, and here is the negative. Okay, so in that cases, in the further what happened in that cases, this is the O minus, that this is the negative, so it is the converted to the double bond O, and there is the formation of the double bond is the here is the occurs. So that is the becomes NH2, that is the double bond O, that is the CH3, and there is the C2H5, C2H5, and that is the CH3. So this ammonia is the react at that position, and removal of the oxygen in the form removal of the oxygen is the occurs, and the water molecule in the form of the water molecule, and the final step we take in the compound which is the, and in the final step we take in the compound which is the pyridine. So that is the C2H5, and in that case the hydrogen present, it is the here formation of the double bond. So that is the derivative of the pyridine, and there is the C2H5, C2H ester is the easily hydrolyzed by the water, or in the presence of the base like etc., etc., like base like potassium hydroxide, etc. And before the hydrolysis of the compound, we have there is the hydrogenation occurs at the 4th position, and that cases this is the and produce the unsaturated compound by the react with the combination of the HNO3 and H2SO4. So nitric acid H2SO4, it is the produce the pyridine and further that is the hydrolysis, and after the hydrolysis of and the hydrolysis, it is the produces the acidic, and this acid in decarboxylation produces the final compound which is the C double, which is the 2,6-dimethyl pyridine. Okay, so the 2,6 substituted pyridine occurs. So this is the important synthesis. Here there is a condensation occurs by the 2 molecule of the ethyl acetoacetate with the formaldehyde, and followed by the methyl type of the addition, and it is the produces the final yield, and that is the 2,6-dimethyl pyridine. Okay, so in that cases we can also take in the 2 molecule of the aldehyde in place of the 2 molecule of the ester. So we can also take in the 2 molecule of the aldehyde like R1CH2CHO plus R1CH2CHO and 1 molecule of the ethyl acetoester. Okay, so only 1 molecule of the ethyl acetoester, and we taken that is the COOC2H5 CH3CH3C11O, and there is the also condensation is the occurs, and this and that cases and it is the produces the final compound which is the substituted pyridine. Okay, so this one is the one, and this one is the important synthesis, and other synthesis involved in that category of that. This is the also obtained from the other ring system, as it is the obtained from the furan derivative like 2-acetyl furan also. It is also obtained by the from the pyrrole, which is a reaction with the chloroform in the sodium hydroxide, as we found in the chemical reaction of the pyrrole, and that is the Riemann-Tienen reaction produces the another compound which is the 6-chloropyridine. So pyridine derivative, there is a various synthetic methodology which focus the study material to synthesis the pyridine moiety, and আমি এখানে ডিটেইলস ডিসকাশন করলাম না প্রত্যেকটি সিনথেসিসের, তোমরা একটু স্টাডি ম্যাটেরিয়াল থেকে নোট তৈরি করে নিও। সোনিকেশন, ইট ইজ দ্য ইম্পর্টেন্ট মেথড যেখানে বাই দ্য অ্যাপ্লাইং দ্য electromagnetic radiation, and this is the produces a compound by the without the solvent system, and sonication means that is the sound system. There is the produces a sound, and due to the sound they are produce the yield or formation of the yield which is the so much higher yield than the conventional method. So sonication method also used for the synthesis of the pyridine molecule also. So you can say, or also by the from the acetylene, and 2 molecule of the acetylene in the presence of the cyanide, we also yield the pyridine molecule. Now going to the chemical reaction of that compound. At the chemical reaction, before the going to the chemical reaction, So draw the structure of the pyridine. As pyridine, that is the nitrogen containing 6-member ring system, and it is the produces in the resonance, and this due to the presence of the electronegative atom, it tendency to the pull down the electron from the compound, and that's why it is the becomes more negative, and due to this negativity there is a resonance positive in the from the resonating structure. We also found that আমি এটা previous class এ দেখিয়েছি resonation in details. There is the positive charge occurs at the dead position 2, 4 and 6 position. So that is the 6 position is also 2 position, so there is the 2 and the 4 position we can obtain positive charge. So that is the this 2 position and the 4 position is the susceptible for the nucleophile attack. Like NH2, like hydroxyl. So there is the nucleophile attack, or it is the react with the tertiary butyl lithium. So this is the one type of the reaction. There is the nucleophilic reaction and another electrophile reaction. So electrophilic reaction, as from that portion you can consider that is the occurs that position, and that is the 3 and the 5 position. So electrophilic is the occurs at the 3 and the 5 position of the pyridine. This is the based on the resonance theory and as well as the electron density of the compound. The important of that is the electrophilic attach or electrophilic substitution reaction. It is in the pyridine, it is the less active to the electrophile than as compared to the benzene. The important that this is that because of the 2 reason, and means I repeated that electrophilic substitution reaction of the pyridine is the less active, or it hinders the electrophilic substitution reaction as compared to the benzene, and this is the due to the 2 reason. And the first reason is that due to the presence of this nitrogen, and this nitrogen is the more electronegative nitrogen, and due to that electronegative nitrogen it puts down the electrons towards itself, so that this around the surface of the pyridine is the become the less electronegative, and due to the less electronegative, and so it's a pi deficient compound. And in the cases of the we found that pyrrole, furan, thiophene, pyrrole, pyrazole, imidazole, that's the pi sufficient compound. So that is the pi deficient compound. That is the one reason to hinders the electrophilic substitution reaction, and another reason is that in the acidic condition it is the produce the pyridinium salt, and due to the pyridinium salt they are the deactivated to the electrophilic or you can say they are the deactivated to the electrophile. So there is the 2 reason of that, and this that's why pyridine normally electrophilic substitution দেখায় না, but in the some drastic condition, some experimental condition, they also substituted by the electrophiles at the position 3 or at the position 5, and that cases this is the also 3 position. When you on the monosubstituted, that is the 1 2 3, and that is the 1 2 3. So this is the normally the substituted electrophile substitution occurs 3 at the 5 position. Okay, so now coming to the electrophilic substitution reaction, follow the study material for the details of that. Like it is the active for the halogenation reaction. Some of the specific condition either when it is the produces the pyridine. This is the 3-chloro and 3-chloropyridine with the formation of the 3,5-dichloropyridine. Okay, so this is the mixture of the 3-chloro and 3,5-dichloropyridine. So chlorination is the occurs in the presence of the large amount of the aluminium chloride. So here the aluminium chloride is a catalyst used for the chlorination. In the bromination we can also take in the drastic condition that bromination, normal bromination is not occurs. It is the occurs in the presence of the oleum and also produces the 3-bromopyridine. Okay, so like that iodination also occurs at the high temperature and in the presence of the oleum. Nitration also occurs, but nitration is the occurs also of in the presence of the nitric acid, the H2SO4 is at 300 degrees Celsius, but the compound which is formed by the nitration, that is the 3-nitropyridine, the yield is the very much low, because this really because it is the normal case electrophilic substitution ke hinders korche. That's why this is the produces the low yield 3-nitrobenzene in practically. But when there is a substitution occurs at that cases, and that is a 2,6-di substituted compound is the occurs, like 2,6-di methyl pyridine when react for the nitration, and it is the react with the nitrating agent, and it is the produces the high marks or greater yield of the 3-nitropyridine, and that is substituted with the 2 and 5 position. So in that cases we taken that electrophile reagent, that is the potassium nitride, and in the presence of the oleum. Sulfonation is the also occurs, but in the presence of the mercuric sulfate, and which is the high mass amount of the catalyst in the presence of the mercuric sulfate. They are just about the temperature 230 degrees Celsius. So they are the produces 3-sulfonic acid of the pyridine. So halogenation, nitration, as I say, and the sulfonation, and another one is the mercuration is also occurs. So mercuration is the also occurs in that cases, but a Friedel curve reaction is not occurs, or the Friedel curve reaction is the not under এখনো পর্যন্ত established হতে পারেনি in the case of the pyridine ক্ষেত্রে, and this is the unknown because this produces when it is the react with the pyridine molecule, it is the form of pyridinium ion, and this pyridinium ion, it is the that is the LCl minus ClClCl. So when the Friedel curve reaction is the occurs, they form a strong pyridinium ion, which is the not reactive of so the chemistry of the Friedel curve reaction is the unknown, and that cases. Okay, so this is in the case of the mercuration, the important of that, it is the attached at the position of that. In that case it is the directly attached at the nitrogen, which is the tertiary nitrogen, and this tertiary nitrogen like that. So that is the pyridine, and pyridine is the mercuration occurs in the presence of the AgOAc2. So that cases there is the like that, there is the AgOAc is the occurs, which is the N derivative, and there is the formation of the another OAc minus. So acetate minus is the occurs, and that cases which is the when treated on high temperature, this HgAc is the rearranged and it is the attached at the position of the 3. So that is the HgOSc. Okay, so at the position of the 3, and this HgOSc, it is the easily mercury converted to the mercury chloride when react with the chlorine when react with the sodium chloride or base, and this mercury chloride HgCl easily substituted with the bromine when bromination is the occurs, and final compound may be obtained, that is the 3-bromopyridine. So this is about the electrophilic substitution reaction. It is the substituted by the electrified under the drastic condition and experimental condition. Okay. So the another important of that in that case is the nucleophilic substitution reaction. And nucleophile is the occurs, as I said, it is the occurs at the 2 or 4 position. And this also established by the resonance, and that is the find that in the cases of the 2 and the 4 position, there is the production of the intermediate resonating intermediate, which is the more stable as compared to the 3 position. Okay, so in that cases nucleophile, the important of that is the reaction with the sodium amide, and this is the known as the a specific name reaction is the known as the Chichi-Babin reaction. So Chichi-Babin reaction, the Chichi-Babin reaction is the pyridine is the react with the sodium amide and to form the aminopyridine. This is the known as the Chichi-Babin reaction. The question may be asked from that portion also. The Chichi-Babin reaction, what is the MOA of the this is the mechanism of this reaction. Let's see that is the pyridine, and it is the react with the sodium amide, and it is the attached at the 2 position, and I say sodium amide is the having the nucleophile, that is the NH2, and it is the attached at that 2 position. So there is the attack of the nucleophile, that is the NH2 occurs, and hydrogen is the open, and that case is the rearrangement is the occurs, and final the compound is the produced, and that is the 2-aminopyridine. And this reaction is the occur. What are the reagent occurs of that cases? The sodium amide, and that is the reaction. This is the occur is in the presence of the toluene at 100 degrees Celsius. The liquid ammonia also used in the presence of the toluene also. Okay, so this one is the reaction. It is the Chichi-Babin reaction. This is the nucleophilic substitution reaction. And in that cases, what is the mechanism of this? Let's try to understand that. So that pyridine when react with the nucleophile, that NH2H, and here is the formation of the negative charge occurs. And further what happened? This hydrogen is the removed, which is the in the form of the sodium hydride. The sodium is the present in the solution form, and this is the formation of the double bond is the occurs, and the rearrangement of the bond is also occurs. So this is the produces a compound which is the aminopyridine. Okay. Like that, it is the also add with the another nucleophile also, as it is the add with the nucleophile like sodium hydroxide, and it is the produces 2-hydroxypyridine. also. Okay. Now going to the reduction and oxidation of that compound. So pyridine oxidation and reduction is also important. Let's see what happened when it is reduced. So important thing on that in that cases that it is the mostly reactive for the nucleophile. আমি যেটা দেখিয়েছি যে ইলেকট্রোফিলিক সাবস্টিটিউশনের রিঅ্যাকশনে ইলেকট্রোফাইলটার অ্যাটাকের সময় এটা অতটা রিঅ্যাকশনের যে স্পিডটা শো করে না এবং এটা হিন্ডার করে বিকজ অফ দা সাম টু রিজন আই হ্যাভ সেড বাট ইট ইজ আ হাইলি রিঅ্যাক্টিভ ফর ইন when it is reacted with the nucleophile. Okay, so now coming because of the electron withdrawing group of the pyridine, like benzene is also the electron withdrawing group. And the reduction cases, this is the reduced by the presence of the various reducing agents. So this is the pyridine when it is react with the ranitidine nickel. In the presence of the hydrogenation occurs at that 120 degrees Celsius, and it is produce the fully saturated compound of the pyridine. This is the known as the pyridine. Okay, and it is also reduced with the lithium aluminium hydride. When they use the lithium aluminium hydride as the reducing agent, and this is the produces the partial saturated dihydropyridine derivative and mixtures of the dihydropyridine, and like that is the produces the this type of the that is the 2,5-dihydropyridine, and another one is the that is the 4,6-dihydropyridine. Okay, so this is the formation of the mixture of the dihydropyridine occurs when it is the reduced with the lithium aluminium hydride. The importance of that is the also produce the fully saturated pyridine when it is the react with the ranitidine nickel as well as the it is the react with the palladium acetic acid reducing agent. So in that cases this is also produces pyridine, and when this dihydropyridine it is the further reduces with the lithium aluminium or excess amount of the lithium aluminium hydride, this is also produces pyridine. Okay, so what happened in that cases the substituted pyridine is the reduction, and the substituted pyridines like pyridine is the substituted with the CH2 C6H5. In that cases reduction in the presence of the palladium carbon, it is from the fully saturated substituted pyridine. Okay, oxidation also occurs in that cases, and it is susceptible to the oxidation. So what happened? Let's see the oxidation cases. It is when oxidized with the hydrogen peroxide acetic acid, H2O2 acetic acid, and it is oxidized from the N-oxide derivative. The question may be asked, what is the form when the pyridine is oxidized with the H2A2 or hydrogen peroxide, and the answer is that it is produces the N-oxide derivative, and this N-oxide is the 8 of that cases. Okay, so when it is that the pyridine is oxidized with the compound, there is a chromium trioxide and the HCl. HCl plus CrO3 chromium trioxide, and it is the form, this conjugation is the formation of the HCrO3 plus Cl minus, and this is the oxidized pyridine, and it is the produced a pyridinium ion NH plus, and this is the pyridinium ion, so that is the CrO3 Cl minus, and this is the known as the PCC or pyridinium chlorochrome. This is the important reagent which used for the oxidation of the various compound in the medicinal chemistry synthesis. Okay, so this is the about the various reaction of that. Now coming to the ring opening reaction of the pyridine. Pyridine is the ring opening when it is the ring open when it is treated with the sodium in 95% ethanol. So pyridine when it is treated with the sodium in 95% ethanol, so hydroxyl, the nucleophile, is attacked at the 2 position as oil, and it is leads to the ring open of the compound. Like that, it is attached at the OH at the 2 position of that, and there is in that cases we are taking that in substituted like NR of that cases, which is the pyridinium ion, and pyridinium ion when it react of that, there is the also plus, and that is the R, and in that cases what happened, and this is the happened the ring opening reaction is the occurs, and this ring opening reactions by the removal of the water molecule and produce the compound which is the known as the that is the CHO. Okay, so that is the CHO. Here is the double bond is the attached at that position, and this is that position. Here is the that position. So there is the ring open occurs, and further when the another molecule of the hydroxyl group is the attached at the that position as a red color, and there is the OH hydroxyl group is the attached at the that position. In that cases, removal of the NH2 is the occurs from the, this is in the form of the RNH2. So minus RNH2 is the occurs, and it is the produce the form which is the known as the glyoxal. Sorry, that is not a glyoxal containing double bond. So that's one is this is also CHO, and this known as the glutaconic dialdehyde. This is the dialdehyde derivative and glutaconic. So question may be asked, what is the form? The question may be asked, what is the form when it is the react with the sodium, when it is the react with the sodium in the presence of the methanol. As I said, the hydroxyl is the react at the as a nucleophile, and it is the leads to the ring opening of the compound, and due to that ring opening of that, there is the formation of the glutaconic dialdehyde. Okay, in the photochemical reaction of the pyridine, it is the produces the Devor pyridine, and this is like that. This is the pyridine, and it is the each new photochemical reaction. It is the produce like that compound. So this is the known as the Devor pyridine, and the another type of the Devor pyridine is also occurs in that cases, and that's type of the Devor pyridine occurs. So remember the name of that compound, that is the Devor pyridine, which occurs due to the photochemical reaction of the pyridine. Okay. So that is the about their synthesis chemical reaction. Now coming to the medicinal uses of the compound, and pyridine is the widely distributed in the nature as well as in the various biological compound. Like that, this is the present in the nicotinic acid, and what are the assignment for that? You have to search the structure from the internet or the book. I will find and draw the structure of you that I draw here the structure of the nicotine, that is the known as the niacin. Niacin, that is the known as the nicotinic acid, and that is containing pyridine and that 3 position carboxylic acid. So that type of the you have to search the structure and also search the uses of the compound. Like nicotinic acid, this is the natural compound, and this is the available in the vitamin B complex, and vitamin B3 is the known as the nicotine. So function, if you know the function of the vitamin B3, like that it is also found in the nicotinamide, niacin, that is the vitamin B3, nicotinamide, okay. NAD is also important in the biological importance of that. It is the important for the various the reaction like the Krebs cycle, etc. So nicotinamide adenine dinucleotide NAD. NAD also contains the pyridine molecule. Okay, so that's is the pyridoxine. This is the known as the vitamin B6. Pyridoxine. Pyridoxine, it is the composed of the 3 compound like pyridoxine, pyridoxamine, and pyridoxal. Both are the pyridine derivative. It is having the specific uses also. Nicotinamine, as I say, that is the nicotine. I said the nicotine. Viscrin. Both are the biologically important compound obtained from the tobacco alkaloids, that is the nicotinal lobecum, and these are the CNS stimulant having the pyridine ring structure. Okay, so another there is the various type of the biological active compound like isoniazide, okay, acididamine, which is the used as the anti-leukemic agent, buchananine, and this is the use for the treatment of the rickets in the treatment, and there is the ethionamide, nicothamine, physostigmine, sulfopyridine. These are the various biological importance of that compound. You have to study the structure and as well as the uses of the compound, which I will give you and then assignment.